Okay, so going back, since z cubed is equal to 1, then we can therefore say the cube root of 1 is equal to, or 1 to the power 1/3 is equal to z. So if we want z, notice how I'm going to put a 1/3 on this right-hand side. I can zoom in slightly so this is better visible. So now I have all of what we've discussed to the power 1/3. If you haven't seen the concept of De Moivre's theorem, I suggest you go back over there. Generally speaking, it allows for us to, almost in a logarithmic fashion, we'll take this 1/3 and bring it down as a power. So it's now 2k pi times 1/3, which is the same as 2k pi over 3. And now we have that z generally is equal to cos 2k pi over 3 plus I sine 2k pi over 3. And this is where we're at, therefore, so far. Now, I've stated here this phrase, if I zoom out slightly, I've said, notice that in exponential form, indices laws also aid us when dealing with 1/3 in a sense of a clear method for simplification. That is to say, and if you haven't seen this form, don't worry too much about it. It can be brought about due to the idea that cos or one way to come to this conclusion in a peaceful manner would be that cos and sine could be written as polynomials, and you can as a result, when these polynomials, especially including the imaginary number, come together, notice that they can be rewritten in the form e to the I theta, where theta would be the value in here and theta would be the value in there. It was a far too simplified way of describing it if you have not come across this form before, but we can go over that in another video, and or you could pause and look it up. It is not too important for this conversation because I will be sticking with this trigonometric form going forward, as I judge it produces a better understanding of the concept for now. But it's interesting to note that if you did have this form, then you had e to the I 2k pi to the power, or multiplied in the indices layer at times by 1/3, and hence you would simply just have 2/3 k pi times I, synonymous to the 2k pi third that comes about as a result of De Moivre's theorem, wherein De Moivre's theorem appears due to the idea of multiplying x plus iy squared. If multiplying x plus iy being z, if you square it, so it becomes x plus iy squared, or cube it, so it's x plus iy cubed. When you do that to cos squared and sine squared, you can use such things as double angle formulae to end up with this proof wherein powers are multiplied into the theta. But that's not where we need to go for now. For now, I would suggest that, let's recap. We had cos 2k pi plus I sine 2k pi equaling 1. Let's not forget that concept, the idea that z cubed equals 1. All I've done then is I've said, since z cubed is equal to this, then z must be equal to this whole thing to the power 1/3. As that is the case, I can multiply 1/3 into the theta due to our brethren De Moivre's theorem.